In this video, we'll discuss the effect of temperature on the rate of an enzyme catalyzed reaction. Okay, so let's begin. Okay, now if we did the experiments, i.e. At a range of different temperatures, we looked at the product formation of a reaction that was dependent on an enzyme, it would look something like that. Okay, the increase in the rate of reaction is more gradual, reaching an optimum and then dramatically falling. Okay, so let's then talk about why this happens. Let's just label our axes. So on this axis we're varying temperature. So now let's discuss what's going on. Okay, so again, it helps to discuss this in its different stages. So what's happening there, what's happening there, and what's happening in the final stage. Okay, so we come back to our basics here. When it comes to temperature, remember that the enzyme has a specific tertiary structure. An important part of that structure is the active site where the substrate binds, and those two have to be complementary in shape for that binding to occur. Okay, so that's our little substrate there. Now, what is happening in this initial stage, i.e. when the temperature is low, is that there is low kinetic energy. Okay, and because of that, there are few collisions between our enzyme and the substrate. And because the rate of collisions is low, we have not that much formation of the enzyme substrate complex. So what's a better way to say that? So because we have fewer collisions, there is a low rate of enzyme substrate complex formation. Okay, and if we're not forming the enzyme substrate complex at a high rate, we are going to have a low rate of product formation. Okay, all right. Now let's look at what's happening as we increase the temperature. So as we increase the temperature, the kinetic energy increases. So we could show that like that. Okay, because there's more kinetic energy, so we are increasing the available kinetic energy. Okay, we increase the rate of collisions between the enzyme and substrate, and therefore we have an increase in the rate of formation of the enzyme substrate complex, and therefore we increase the rate of product formation. Okay, so remember, I'm abbreviating it a bit in my comments, but you do have to refer to the rate of product formation. Okay. Okay, now what is happening further on? So if we increase the temperature even further, what's happening? We should mention that this temperature reaches an optimum rate of, or the temperature, if we increase it to the right level, we're going to reach a level a temperature where we reach the optimum rate of reaction. Okay, that's the optimum temperature. But what happens when we increase the temperature beyond that? Okay, so the main point is that we are making further increases to the available kinetic energy. Okay, and yes, that is going to make more collisions. Okay, but here the question is, are those collisions still resulting in the formation of the enzyme substrate complex? So I guess we should all be comfortable with the idea that increases in temperature lead to the denaturation of the enzyme. Okay, so the active site is no longer complementary to the substrate. Okay, we don't assume that there's any change in the shape of the substrate. Okay, so enzyme tertiary structure is affected. So let's just go through that step by step. I guess the main idea here is that the active site no longer is complementary to the substrate, can't form the enzyme substrate complex. So let's discuss what's going on. Okay, so increase in kinetic energy causes an increase in vibrations. Okay, and these vibrations break bonds which are responsible for the tertiary structure of the enzyme. So which bonds are we talking about here? Hydrogen bonds. Okay, they can break due to high kinetic energy. Ionic bonds. Now they are stronger than hydrogen bonds, but if you give enough energy, they will eventually break as well. The bonds that don't break due to temperature in a protein is the disulfide bonds. Okay, so the more disulfide bonds you have, the more resistant the protein will be to denaturation. So if these bonds are breaking, we get a change in the shape, in the tertiary structure. Okay, and we get a change in the shape of the active site, and as a result we cannot form the enzyme substrate complex at the same rate. So the rate of the product formation decreases. Okay, and that's the key point. Remember, if you're asked a question on how a factor affects the rate of a reaction, you always have to bring it back at the end, even though you've discussed all the relevant points such as kinetic energy, bonds breaking. You always have to bring it back to, well, how does this affect the enzyme substrate complex formation, and ultimately how does it affect the product formation, because it's that we are measuring on this axis. Okay? Easy.